In Part 5 of Lecture 3, we will discuss overloading methods and writing constructors. A precondition states what is assumed to be true when the method is first called. A postcondition states what is assumed to be true when control is returned to the calling method. This makes it very clear who has responsibilities for what. Whoever is writing the method that is doing the calling is responsible to make sure that the method's preconditions have been met. On the other hand, whoever is writing the method that is being called is responsible for making sure that the postcondition of the method has been met. Frequently, there can be more than one way of doing a task, depending on what is available. If we look at computers handling arithmetic, we know that there will be an instruction to add numbers together if they are both integers. And we know that there will be a different instruction, at least on the machine language level, if the numbers that we're adding together are floating point. We take this a step further if we look at a plus sign in a modern programming language. X plus y, and if both x and y are numbers, will indicate that we are doing addition. But if I'm looking to add s and t together, and they are both strings, the assumption is that what I'm doing is concatenation, placing one string with the other string immediately after it as one string. This is just one example of overloading. There may be more than one method that shares a common name that do essentially the same job, but the details of the methods may differ. They must differ by parameter lists. This is what we call overloading a method, and we will be doing our share of it over the course of the semester. We need to discuss the rules for overloading. Although overloaded methods can have different return types, it is essential that they have different parameter lists. These parameter lists can differ in the number of parameters or in the type of parameters. They can even have parameters of the same type and same number if the order is different. So if I have one version that has an integer followed by a double in its parameter list, I can have another one with the same name that has a double followed by an integer. Their exact algorithms can even be different, although the assumption is usually made that they are different ways of doing the same jobs, but with different types of data. We are now going to look at our sixth try to write a class for date. As before, we will only look at the bold-faced lines. These are the only ones that have been either changed or added since our last attempt. Here you'll see that we have public class date sixth try. This is preceded by the import statement for the scanner class and the declaration for our properties month, day, and year. Here you see the code for setDate, a mutator that changes all three properties of the object. You'll notice that the month is given in numeric format. This will allow us more easily to confirm whether the month is valid. If all three are valid, we change the values that we're saving. Otherwise, we print an error message and we quit. Here we have a new version of setDate. Again, we are looking to change values for month, day, and year. But this time, rather than giving the month as a number, we're going to use a string to represent the name of the month. We begin with a comment, setDate, a mutator that expects the month in string format. The header for the method is public void setDate, string month string, int day, int year. After the open brace, we check it with if date OK, month string, day year. This month equals month string. This day equals day. This year equals year. Clearly, we will need a different version of date OK as well. We then have the else, system out println fatal error, system exit 0. This is what we will do if the month, day, or year is invalid. All it will take is one of the three to be invalid. We now look at one last version of setDate, beginning with a comment that says, a mutator that assumes that the day is the first day of the specified year. In other words, January 1st. Public void setDate int year, and then we call setDate 1 year. We make use of one of the previous two setDate values to call this one. We now have date OK. This is the version we saw before, where the month is given as an integer. We now have an additional version of date OK. Returns true if the date is valid, returns false if the date is invalid. Assumes that the month is in string format. Public boolean date OK, string month, int day int year int. Return month OK, month string. And day int is greater than or equal to 1, and day int is less than or equal to 31. And year int is greater than or equal to 1,000, and year int is less than or equal to 9999. Given that the month is a string, we will have to compare it to the 12 names that we have for the months. If it matches one of them, it's good. If it doesn't match any, it's not. Month OK returns true if the month is one of the 12 valid strings. Returns false if otherwise. Public boolean month OK string month. And we will start with returns month equals January or month equals February, and so on until we reach or month equals December. We will now close the brace for month OK. There may be additional methods here that we had earlier that we're not showing, but then we'll have a brace to end the entire class. A constructor is a special type of method that is called when the object is created. When you write my class, my object equals new my class, you are calling the constructor. This is important because constructors will set aside space in memory for the object's data, space for its properties, space for references to its methods, and the private data that its objects will need. A default constructor does not have any parameters. This very lack of parameters is why we call it in effect by default. It assumes that some initial value must be supplied. You can see in this example, date, a default constructor for the class. Public date, month equals January, date equals 1, year equals 1000. A conversion constructor provides initial values for the various properties of the object. We call it a conversion constructor because we are converting this collection of values into one object. Sometimes there may be multiple conversion constructors depending on the type of the data that's supplied. In this case, you'll see here, date, a constructor that accepts the month in numeric form. Public date, int, month int day, int year. Set date, month int, day year. In this way, the constructor will call a mutator that will set the values for the date. Here we see the other two versions of the conversion constructor. Date, a constructor that accepts the month in string format. Public date, string, month string, int day, int year. Inside the method we call setDate, month string, day year. Below the last of the three constructors, date, a constructor that assumes that the day is the first day of the specified year, in other words, January 1st. Public date, int year. Set date, 1 year. In all three cases, we are using variations of the mutator for the whole object, and in its different forms that we will give it data. Here we have a driver that will allow us to test the constructors that we have written. Public static void main string arg, date, date1 equals new date December 16th, 1770. Date 2, new date 1/27/1756. Date 3 equals new date 1882. Date 4 equals new date. System out println, whose birthday is date 1 question mark. System out println, whose birthday is date 2 question mark. System out println, whose birthday is date 3 question mark. System out println, whose birthday is date 4 question mark. A close brace for the method and for the class. In our output, whose birthday is December 16th, 1770. These are literally the values of date that we had in the conversion constructor. Whose birthday is January 27th, 1756. Here you see that we converted the 1 into January and printed the date. Whose birthday is January 1st, 1882. We only gave in the constructor the year 1882, but by default it set the day as January 1st. Whose birthday is January 1st, 1000. Here we called the default constructor, which by default set the month to January, the day to 1, and the year to 1000.